What's going on, everyone? In today's video, we're going to be taking another look at yet another word problem that involves quadratics, and you'll see just how easy it is as long as we have the right tools to solve it. Let's get into it. We're given that if we're looking at a suspension bridge from the side, and this is a very, very typical looking suspension bridge, and these do in fact model a quadratic equation, we find through some tests or some surveys or some mathematical models that we're given that f of x is equal to 0.0009722x squared. I always like to count the zeros, so when I put it in my calculator, I know how many to put. It's really easy to mess that up. Minus 1.167x, where x is the horizontal distance in meters, and f of x is the depth or kind of the height in meters. So let's go ahead and plot the graph of the function. So I'm using the Ti-Nspire. And as you can see, when I graph it, I kind of get something that, looks pretty good and looks relatable to what a bridge might look like. And you'll see that I have 0, 0. I have 1200.37. We'll round that to 1200 for significant figure purposes as my zeros. And then here's my x. And if I wanted to, I could also just go ahead and find out my minimum value here and here. Right there, 600, negative 350. So I have the graph. It depends on the context of the question. Sometimes you might need to sketch this, sometimes not. But if you are asked to sketch this, just remember you're going to need your y-intercept, your x-intercepts, and then, of course, your vertex and have the correct shape. But this will obviously help you out tremendously. So let's go back. So let's find the coordinates of the points where the graph crosses the x-axis. I already did that. 0, 0, and 1200, 0. Again, I'm rounding just for significant figure purposes. Let's go ahead and call that 0, 0, as well as 1200, 0. All right, so let's use these values to write down the equation of the axis of symmetry. So again, if we have our x-intercepts, this process is really easy. Because again, I could use negative b over 2a with this, but another way to do this is to find my average of my x-intercepts, which would be 1200 over 2. And that way I can find that this is, oops, I don't know why the line is there. 0 plus 1200 over 2. That way I can find out what my answer would be, which in this case is just x equals 600. Okay, again, and keep in mind that we are rounding, so your answer might be slightly off. It depends on if you're supposed to round to a certain number of decimals, do whole numbers, significant figures, whatever your teacher or the question asks for specifically. So now let's take a look at how to find the y-coordinate of the minimum. So now I already did this for you on the graph, 600, 0.185, but again, I'm rounding here, and negative 350. If you were asked to solve this by hand, it still wouldn't be that difficult, because if you think about it, I have 600 right now as my x-coordinate of the vertex, which also gives me the axis of symmetry. If you plug this into your equation, well, think about it. It's the x-axis of the x-coordinate of the vertex. So if you plug that in, you will of course get out your y-coordinate of the vertex, which in this case, as you can see from the graph, is going to be a minimum value. So let's go ahead and do that. Let's find f of 600. It's going to be equal to 0.1239722 600 squared minus 1.167 times 600. There we go. And if you get that into your calculator correctly, you will find that f of 600 is going to be equal to negative 350. Again, some rounding going on here depending on the context of the question, what your teacher's asking, but that's also exactly what we find here, about 600-ish to negative 350-ish. Good. So now let's go ahead and describe in context what the minimum point represents. Well, if you think about what this is modeling, it's modeling a bridge, right? Or the suspension of a bridge. So what this point is saying, negative 350 and 600, which is going to be your vertex, 600, negative 350, it is going to be the coordinate of where this suspension is the lowest on the bridge. Okay, so remember, when you're dealing with quadratic equations and word problems, we're really going to be focusing on what that maximum or minimum value is, that vertex is, in context of the question. So in this case, it's going to be right here. It's going to be where my suspension reaches its lowest point. Okay, hope that helped. So you can see that we can really use our graphing calculator and some basic equations to really tackle these multi-step problems with, kind of problems within problems. So I hope that helps, and I'll see you all in the next video. Take care.